Everything you thought you knew about the cosmos is a lie, or at least a relic of an outdated reality. We were taught that Earth drifts through a perfect vacuum, that the sun is a simple ball of fire, that a fixed center of the universe anchors the heavens. But what if the science you memorized in school is nothing more than a carefully crafted illusion? Imagine the iconic images of Andromeda, the sun, the moon shattering like fragile glass, each fragment exposing a deeper truth. Picture the sun not as a glowing ember, but as a roiling sea of plasma, magnetic filaments dancing in a choreography of nuclear fusion. Visualize a translucent grid of space-time bending under the weight of an unseen probe, gliding along a curvature that defies the textbook notion of empty void. In the next 6 minutes, we will dismantle 3 pillars of the conventional picture of the universe: our perception, the simplifications of textbooks, and the foundations of physics themselves. Prepare to confront the shadows that have long concealed the true nature of space. But first, let us examine how our very senses betray us. The so-called dark side of the moon never remains in perpetual darkness. As the moon orbits Earth in synchronous rotation, the sun illuminates each hemisphere in turn, painting a lunar landscape that is constantly bathed in light. Visualize the moon's surface turning from night to day over a single month, each side receiving the sun's kiss. And consider the stars that speckle the night sky. To the naked eye, they appear white, a uniform sea of points. Yet each star radiates a distinct hue dictated by its temperature: blue for the hottest, red for the coolest, yellow and orange in between. Imagine a constellation where every point pulses with its true color, a cosmic rainbow hidden behind the limits of human vision. These revelations are only the beginning. As we move deeper, we will uncover how the scales presented in textbooks compress billions of kilometers into a few pages, how Neptune's true shade is a pale teal rather than the vivid blue we have been shown, and how the definition of a planet was reshaped by the discovery of Eris. If this glimpse into the hidden layers of reality resonates with you, share your thoughts in the comments. I'm eager to hear how you interpret these cosmic deceptions. As we turn the page to the next chapter, the textbooks that have guided generations begin to crumble under the weight of precision. Picture a model of the solar system drawn on a single sheet of paper, each planet spaced neatly as if the cosmos were a tidy office desk. In reality, if we were to compress the true distances into a linear representation, the span between Earth and Mars would stretch beyond the length of an entire highway, and the gulf between the outer giants would span continents. Imagine flipping through a volume whose pages were a kilometer thick, each leaf a kilometer of void, before you even reach the orbit of Saturn. This is the scale that ordinary diagrams invisibly erase, giving the illusion that the planets dance in close proximity, when they are, in fact, separated by unfathomable expanses of emptiness. Now consider Neptune, the distant world whose iconic hue has been forever etched into our collective imagination as a deep, electric blue. The Voyager missions captured a shade that, after decades of processing and artistic enhancement, presented a vivid sapphire. Yet, recent spectroscopic analyses, refined by the James Webb Telescope, reveal a far more subdued palette, a pale teal, tinged with green, that mirrors the subtle coloration of its sibling Uranus. Visualize the planet bathed not in a dramatic ocean of blue, but in a gentle wash of sea foam, a reminder that even the most celebrated images are filtered through human perception and technological limitation. The saga of planetary classification offers another striking example of how a single discovery can upend long-standing doctrine. For centuries, Pluto occupied a cherished position as the 9th planet, a distant sentinel at the edge of the solar system. Then came the detection of Eris, a body slightly larger than Pluto, orbiting far beyond the Kuiper belt. The astronomical community was forced to confront a paradox. If Pluto retained its planetary status, the definition would have to expand to encompass dozens of similar icy worlds, diluting the term to the point of meaninglessness. The resolution was a new category: dwarf planets, where both Pluto and Eris now reside. Imagine the intellectual upheaval of rewriting textbooks, of teaching new generations that the very word planet is a compromise, a placeholder for an evolving understanding. Having stripped away the comforting simplicity of classroom sketches, we now descend into the deeper currents of physics, where even the most fundamental concepts demand reconsideration. The popular narrative of the Big Bang portrays a colossal explosion, a fireball hurled outward into pre-existing space. In truth, the event was not an explosion at all, but an expansion of space itself, an inflationary burst that stretched the fabric of the universe from an infinitesimal point to a cosmos of staggering breadth. Picture a balloon being inflated from a single speck, its surface representing space-time, every point moving away from every other as the balloon swells, not because matter is thrust outward, but because the space between points is growing. This subtle shift transforms the origin story from a violent outburst to a graceful, geometric unfolding. Equally profound is the modern view of gravitation. The centuries-old notion of a mysterious, invisible force pulling objects together has been supplanted by Einstein's insight that mass warps space-time, creating curves along which objects travel. Visualize a heavy sphere placed upon a stretched rubber sheet. The sheet sags, and a smaller marble placed nearby rolls inward, not because the sphere exerts a pull, but because the surface itself guides its motion. This curvature dictates the orbital paths of planets, the trajectories of light, and the very flow of time near massive bodies. It is a paradigm that replaces the idea of force with the elegant language of geometry. These revelations, though unsettling, are not signs of failure, but markers of progress. Each correction, each refinement, peels back another layer of the cosmic veil, inviting us to see the universe with ever sharper eyes. As we stand on the cusp of new discoveries, probing the atmospheres of distant exoplanets, mapping the dark matter web that scaffolds galaxies, listening to the faint whispers of gravitational waves, we must ask ourselves, what other truths that we cling to today will dissolve under tomorrow's scrutiny? The answer lies not in certainty, but in curiosity. Let the questions linger. If the colors of distant worlds differ from what we have imagined, how might that alter our search for life? If the definition of a planet is fluid, what does that say about the categories we use to comprehend the cosmos? If gravity is geometry, what new technologies might we devise by shaping space-time itself? Your voice is part of this ongoing dialogue. Share your reflections in the comments below. What concept challenged you the most, and what mystery do you hope future missions will illuminate? If this journey through the hidden architecture of space resonated with you, consider lending your support by liking this video and subscribing to the channel. Your engagement fuels the pursuit of deeper insight, ensuring that together we continue to question, explore, and expand the boundaries of what we think we know. The universe is vast, the unknown infinite, and the next revelation may be just a thought away.